In this question, a rectangle is inscribed in a circle of radius 3 centimeters and center O as shown in the diagram. Now, the point P is a vertex of the rectangle and lies on the circle. The angle between OP and the x-axis is theta radians, where theta is between 0 and pi over 2. Now, that's very important. This condition here is very important because we may have to use it during the solution. Okay, so let's carry on. They're saying, they're asking us to write down the expression in terms of theta for x. Now, I'll just go back to that diagram. Now, in this diagram here, we have this type of a situation. We have a triangle here. This angle is theta. Now, this is the x coordinate, and this is the y coordinate. Obviously, from there, you can see that by applying SOHCAHTOA, okay, you know that sine is opposite of a hypotenuse. So you can say sine theta will be equal to y over 3, which means that y will be equal to 3 sine theta. And then we also have cos theta is equal to x over 3, which means x is equal to 3 cos theta. And these are basically the expressions that these guys are asking for you in part A1 and A2. So you can just go ahead and write the solutions here and say that x is equal to 3 cos theta and y is equal to 3 sine theta. Okay, and then show that the area is given by that. Now, if we go again back to the diagram, we can see that the length from here, the length of this rectangle is actually 2x, okay? And because x is 3 cos theta, this will be equal to actually 6 cos theta, all right? 3 lots of 3 cos theta. So that will be 6 cos theta. Remember, this is 2x. Yeah? And the height here will be 2y. And what is y? Y is 3 sine theta. So this will be 6 sine theta, which represents 2 lots of y. Okay? So which means that the area of this, okay? So if we want to find the area of this guy here, area, or let me write this below here. So what we have is this. And this is for question B. So for B, we have a rectangle that looks something like this, okay? And we have 6 what was it again up there, 6 cos theta length, so 6 cos theta and 6 sine theta, all right, 6 sine theta, and the area of this will be equal to 6 cos theta multiplied by 6 sine theta, which will be equal to 36 sine theta cos theta. We can write this as, because they're asking us to write that answer in this form, back again, because they're asking us to write this answer in this form, this form here in terms of sine 2 theta, then we have to find a way of rewriting that, which means this can be written as 18 into 2 sine theta cos theta. Okay, there's a reason why I am rewriting this. It's because not that sine 2 theta, sine 2 theta, sine, this is from trigonometry, is 2 sine theta cos theta. So we are going to use this here, okay? We're going to use this here. So, which means our answer here will be 18 sine 2 theta, okay? And that is what you're required to do for part B of this question, okay? Show that the area is given by that. So we have it here. Okay, let's carry on. Part C of this question is find dA over d theta. Okay, remember the area is equal to that. So C1 dA over d theta is just the derivative of this function, which will be 18 cos 2 theta. So that's outside inside 2, which means you get 36 cos 2 theta. Okay, C part 2. We are required to find in part 2, find the exact value of theta which maximizes the area. So which means we need to find the critical point. Okay, so we know that the maximum value of theta, we know that maximum value of theta occurs where are the critical points. So that occurs where dA over d theta is equals to 0. So we have an expression for the derivative, which is here. So we're just going to equate that to 0 and solve for it. So which means 36 cos 2 theta will be equal to 0, which means that cos 2 theta will be equal to 0. Now we need to solve for that. To solve for this, you need to go back to the unit circle, okay? And on the unit circle, we know that for any angle theta, the x coordinate is represented by cos theta, and the y coordinate first by sine theta. The coordinate at this point is this point is 1, 0. Here it's negative 1, 0. Here it is 0, 1. Here it's 0, negative 1. Okay, so by inspection, you can see that when cos theta is equals to cos theta is actually the x coordinate, and we want to find where cos theta is equals to 0. Okay, that's what you're interested in. So that will be at this point and at this point. What angles are those? This angle here is 90 degrees, and this angle here is 270 degrees. Okay, so you can go back here and say that, well, theta will be equal to 90 degrees. Actually, not theta, because it's 2 theta here, right? Because you have to be careful with that. So 2 theta is equal to 90 degrees, or 2 theta is equals to 270 degrees, which means theta will be equal to 45 degrees, or theta here will be 135 degrees. 135 degrees. But we are not working in degrees. We need our answers in radians, okay? So what we need to do is convert this to radians. So we can go ahead and say theta here will be equal to 45 pi over 180. And theta here will be 135 pi over 180, which will be equal to pi over 4, and this will be 3 pi over 4. Okay, so theta, either theta is equals to that, but we know that from the question we have this condition that theta has to be between 0 and 0 and pi over 2. Okay, but theta is between theta is between 0 and pi over 2, which means that won't work for us because it's outside the domain. So which means that theta is just equal to pi over 4. Okay, now we have to go back again and see what the next question is asking. So use the second derivative to justify that this value of theta does give us a maximum. So we need to use the second derivative. Now the first derivative is here, so we need to differentiate that to get the second derivative. So the second derivative will be, this is now part 3. The second derivative will be equal to negative 36 sine 2 theta multiplied by 2, which will give us negative 72 sine 2 theta. That is if you differentiate that first derivative there, this one here. Just differentiate that and you should be able to end up with what I have here. Okay, so now at theta is equals to pi over 4, what will be the second derivative? Okay, that will be equal to negative 72 sine 2 theta, which is pi over 4, and that will give us negative 72 sine pi over 2. Now this is same as negative 72 sine 90 degrees, if you think in terms of degrees. And if you come up here, you can see that sine 90 is 1. Okay, so that will be equal to negative 72. Okay, just be negative 72. So what can we say? We can say that since the second derivative is less than 0, then the maximum area occurs at this point where theta is equals to pi over 4. It's confirmed, it's justified. So since the second derivative is less than 0, then the maximum area, because you're talking about area here, occurs where theta is equals to pi over 4.